I'm Andrew Briggs. I'm Professor of Nanomaterials at the University of Oxford. Thermodynamics is the science of heat and work. Thermodynamics tells you about the exchange of energy. When you apply the brakes in a car, the energy of motion is converted into heat, and the amount of heat depends on how big the car is and how fast it was travelling. That's the first law. Work and heat are interchangeable, and the total amount of energy stays the same. But the first law does not tell you about the direction of flow of energy. Why does heat flow from a hot object to a cold one, but not the other way round? Why can all the energy of motion be converted to heat in the brakes of a car, but not all the heat from burning fuel can be turned into making the car move? The answer was found by realizing that in physical processes, energy tends to disperse. The dispersion is expressed by a quantity that has a name: entropy. This is described by the second law, which says that the entropy of an isolated system can stay the same or increase. It usually increases, but it can never decrease. When you brake in a conventional car, the energy is irreversibly converted into heat and the entropy increases. When you brake in an electric car, the energy, or some of the energy, can be stored in the battery, and the increase in entropy is less, but nevertheless it does increase. The second law of thermodynamics has some dramatic consequences. Since the entropy of an isolated object cannot reduce, the universe itself is condemned to see its energy irreversibly dispersed until reaching a state of maximum energy when no more reactions can happen. In 1867, the universality of the second law of thermodynamics was challenged by an amazing Scottish physicist by the name of James Clerk Maxwell. He proposed a thought experiment which, if it were realized, could reduce the entropy of a gas. His idea stimulated years of debate amongst physicists, but only now, with recent progress in nanotechnology, has it become possible to devise an experiment to test it.